Please welcome to the stage the CEO and co-founder of ForgeFX, Greg Meyers.
All right, what a great stage we've got here. This is a great theater. Thank you everybody for coming. I hope that everyone is enjoying CONEXPO-CONAGG so far as much as I am. Really want to appreciate everybody who has come to see my session here in Las Vegas, and for everybody watching on the streaming channel and for those watching around the world. Really appreciate you taking the time. I want to start today with a question. My session is obviously entitled From Iron to Impact. But the question is, how do you train people to operate million-dollar pieces of equipment where the risks and the financial ramifications are very intense, where one mistake can shut down a complete operation? And this isn't really a theoretical question. This is the reality for many of you in the construction industry every day, where one accident can literally stop production and cost millions of dollars. So the question really becomes, how do you train for multi-million-dollar pieces of equipment and remove that risk and remove those financial ramifications? My name's Greg Meyers. I'm the CEO of ForgeFX Simulations. We're one of the leading training simulator development companies in the construction industry. And today, I'm going to tell you exactly how we answered those questions and solve them for our customers. So at ForgeFX, we build digital replicas and virtual twins of our customers' different pieces of equipment, their processes, their procedures, in order to produce training simulators that allow them to remove that risk and train virtually. And these are the types of jobs we're talking about working on. Big pieces of equipment, high impact job sites that do not have any room of error. And so what we do is we build digital replicas of all those different pieces of equipment, fully interactive, fully virtual, acting just like the real-world pieces of equipment that allow you to train your operators completely virtual without having to risk real-world equipment. And so this is what that looks like, where we take a virtual reality headset, we take the real-world controls off equipment, we build simulation software that allows you to really replicate those job processes without having to risk consumables, without having to damage equipment, and without having to take equipment off the production line where it's making you money. And it's not just operator training. We also do a lot of maintenance and service training. We're able to use advanced mixed reality technologies to allow folks to train to, as you're seeing here, do maintenance, do service training without having to, again, take a piece of equipment off the line. And we're able to use spatial reality technology that allows us to really put someone in these situations without having to have a piece of equipment or parts available for them to potentially damage. And what you're seeing here is all parts of the training simulator that we built for Caterpillar. This is a fully interactive training simulator that allows operators to train for operation as well as maintenance of these excavators. And the way we do what we do is we are 3D graphic specialists. We are all ex-game developers who have an expertise in creating 3D assets that look and feel just like the real ones, but operate at a very high frame rate and can really perform well so that they feel just like the video games that kids play, but they are not for entertainment, they are for training. And then the other side of our house are, like I said, game developers. We leverage lots of the latest and greatest video game engines like Unity and Unreal to build our products so that they feel and look and are as immersive as video games, but again, not for entertainment, to really get someone to interact with these pieces of equipment. And then on top of that, we layer real-world physics. So it's not just about how does this piece of equipment work, how do the buttons work, how do the controls work, it's how does it interact with the real world? What are the particles like? How's the fluid dynamics? We layer all of that into our simulator so that you are experiencing what it's like to interact with the materials that these pieces of equipment work with. And then underpinning that is our intellectual property, the Forge Sim framework. This is a simulation domain-specific framework that we wrote over the course of our being in business for 20 years that allows us to repurpose lots of components that many of these simulators share in order to very rapidly build products and deliver them for our customers. And what that also allows us to do is to deploy cross-device and cross-platform. So every single simulator that we run works on an iPad, works on a phone, VR headset, AR headset, desktop. We are really device and platform agnostic. And so that allows us to build applications that really put someone in the controls, give them the opportunity to do the job that they're going to be asked to do, but again, do it completely virtually. Let them fail. How many times have you been in an experience where you're like, oh, I'll never do that again? Let's let them do it here so they never do it again in the real world. And we have a unique perspective on the industry. We've been in business for 20 years. We've had the pleasure of working for many global brands, but our roots are in heavy equipment and in construction equipment. You can see we work for Caterpillar, Komatsu, JLG. We've also just become a vendor for John Deere, and I'll talk about them more in a moment. But it really gives us a unique perspective to not only see how different training challenges arise, but also what patterns work across industries. And that's what I'm going to try to explain to you today. But before I dive into that, one of the things I want to mention is that we've had the ability to see where simulation-based training fits into all these different organizations. We are not trying to replace training departments. We are trying to augment them. We are trying to help them train their trainers. And so what we've seen works the best is we start with instructor-led training, then we move to simulation-based training to do familiarization of the equipment, the controls, get a good understanding of how it works, then put your hands on real iron, get in the dirt, really operate the equipment, and then go back to the simulator for reinforcement training. That's what allows things to scale. Oftentimes you have a very limited amount of time to work with a piece of equipment. This allows you to have unlimited amount of time with that same piece of equipment. And so the challenges that we see are that, especially in the construction industry, 92% of firms are struggling to find workers. They cannot find enough workers. There are also more than 1,000 deaths annually in the construction industry. And finally, 500,000 unfulfilled jobs. So it's not only about hiring people, but it's about hiring skilled people and keeping them safe. And so these are the challenges. These are the real pressures that we are trying to help our customers overcome. It's not so much about the technology, it's about the results that this technology can deliver. And what do we deliver? We deliver 40% faster skill acquisition. If you're running a training department and you know how long it takes to get skilled workers up to speed, being able to reduce that by 50% is significant. Also, our training simulators are networked multi-user applications. So I put on a headset here in Las Vegas, you put on a headset in New York, we're able to connect and train as if we were in the same room. This dramatically reduces your travel budget. We're able to save some of our customers 30 to 50% in their travel budget alone. And I've gone out of order, I see. So we are also able to reduce training budgets by not having to take real-world pieces of equipment out of production, by not using consumables, by not destroying machines. There's a statistic that says 20% of your worst employees do 80% of your damage. So if we can get those novice employees trained, we can reduce a lot of that damage, and ultimately that drives profit back to our clients. So the way we do this is through delivering increased engagement and knowledge retention. So we were able to standardize training so that different trainers who are training differently around the world all now have one standard training tool. And we do that through immersion and interactivity and lack of distraction and gamification, really get the people involved with the content that we're delivering. And then it's cost effective, like I was mentioning. We're reducing the amount of time you have to travel. We're reducing the consumables. We're reducing the wear and tear on actual pieces of equipment, again, leading to a cost-effective training program. And then we remove all those safety hazards. So your brand new operator who's never operated an excavator, you can put him in that excavator. You can let him make those mistakes. Not something you can do in the real world where you can say, well, go, and if you tip it over, you tip it over. Here, we want you to tip it over. You wouldn't build a flight simulator that doesn't allow you to crash the plane. We want you to crash the plane in our simulator so you don't do it in the real world. So the first company I want to talk about is JLG Industries. If you're not familiar with JLG, this is the type of work that they do. They're operating at heights. No room for error here. And so what we've done with them is we identified their training challenge, right? High elevation work, very safety critical environments. And the machines are growing more and more complex, but the constraints are still the same. You've got limited access to equipment. The dealers train slightly different. And then there's a business impact. slower time to conversion, increased safety exposure, and limited training scenarios or scalability. It's very difficult to scale instructor-led training, right? So here's an example. Here you've got one trainer, one trainee, one piece of equipment, and everybody else is standing around. Some guy went to get coffee, two people in the bathroom, but this doesn't scale, right? This is just not a way to be able to scale training. So what we did for JLG was we developed Axis Ready Fusion XR. This is a fully functional VR training simulator that takes the real-world controls off either an aerial work platform or a scissor lift, has tons of scenario-based applications within it, so you can train for the actual jobs that you're going to be doing. We've got this at our booth at N10330 if you want to come check it out, and you can also purchase this directly from JLG now. And it's not a video game. This is a training simulator. We've taken the real-world controls, married it with our simulation software, and then with the VR headset, you get stereoscopic 3D, you get positional tracking, head tracking, hand tracking, really all of these elements that make it very immersive, give you a sense of presence in the application, unlike any other software can, because you really feel like you're inside of it. And that allows for adoption. People who feel immersed in it, they buy into it, and they begin to use it. And so the goal wasn't just immersion, though. It was about being able to provide repetition without risk, being able to give folks the ability to use the equipment, make those mistakes, and repeat until they don't make those mistakes anymore. Here's an example of that simulator. You can see a user is wearing an off-the-shelf headset, hooked up to the real-world controls, and learning how to operate a piece of equipment. Completely risk-free, we're not burning consumables, no one's at height, no piece of equipment had to be taken out of production. And we really want you to fail here. We like to say at our company, failure is the goal. If we can get you to fail in our simulator and feel what it's like to have an accident and turn what would be a catastrophic accident into a phenomenal learning experience, the simulator has done its job. This guy who just experienced in this simulator is very unlikely to make that mistake in the real world. And so here's why it worked. We were able to accelerate skill development, safe repetition, muscle memory, scenario-based hazards, really giving you the ability, again, to go through your job site, fail, and learn the lesson from it. And then reduced operational constraints. There was no need for real-world equipment. We did not have to have instructors there all the time. By the time someone got to a real-world instructor, they had already become familiar with the equipment. And the curriculum became standardized. Every time someone put on the simulator or used the simulator, if they were in this country or another country, it was the exact same program. No variability from trainer to trainer. Everyone got the exact same standardized training. In addition, one of the things that we learned was that training anywhere, anytime was also very valuable. So like I mentioned before, our simulators run on a variety of platforms. This application also runs on an iPad and a standard PC. So you buy a piece of equipment from JLG, that same day, you can download an iPad app that'll at least teach you machine control familiarization. So when that machine shows up, you've already learned how to operate the piece of equipment. And so the impact was pretty significant. We were able to rapidly increase readiness. We were able to increase throughput, and we were really able to remove a lot of the safety concerns that a lot of our customers had. The insights that we gained, as I mentioned, that VR was great for high fidelity, really gave people the feeling that they were in there, let them buy into it, and let them really experience the equipment. The desktop was phenomenal for scale. Everyone has a PC at home. The software is available on a desktop. People could go home and use it at home, wake up in the middle of the night, curious how their equipment's gonna work, very easy to access. And then running on a mobile device meant that they could have it with them in the field. So if you're in the field and suddenly you don't know how to use it, you open up your mobile device, quickly run through a scenario, right, that's how I do it, and get back to work. Now I'd like to move on to another example. Very different challenge, but a very real challenge. If you know about Vermeer, they build horizontal directional drills. We build their training simulators for these drills. And that's what these equipment looks like. It is a very large piece of equipment where you're drilling large shots underground to pull utilities or different fiber lines. And one mistake with one of these pieces of equipment can ruin a day. You hit a power line, you hit a water main line, your job site is not only over, but now you're looking at fines and you're looking at ramifications. And these guys operate these pieces of equipment trying to understand what's happening underground, sometimes hundreds of yards underground, just with the controls and the dials and the gauges. They're trying to understand what's happening. And they were having a real challenge getting users to understand that mental mind's eye that you need to have to understand what's happening underground. And so the Vermeer Corporation Horizontal Directional Drill Simulator came about, where we were able to tackle one of their biggest challenges. And that was the fact that there is zero line of sight in this job. You do not have a line of sight into what you're doing because your drill is underground. And so our simulator allowed you to understand how the controls work, to really get a feel, to develop muscle memory for the job. Again, this isn't a video game, right? This is a training simulator that is training someone for a critical task. So we were really trying to get people to be ready for operation. They had to understand that this was something that was going to be a very dangerous thing to do, and they had to do it correctly. And the hardest skill wasn't the machine again. It was the spatial awareness. So for here, the question became, how do you train someone to see something that's invisible? And so the answer was simulation. In our training simulator, after you master the equipment here, after you learn how to use all the controls, we do something that you cannot do in the real world. We take you underground. We show you where that water main line is. We show you where those hazards are so that you start to develop that mental mind's eye that sometimes takes seasoned operators years to develop. That really was the changing point for Vermeer. It allowed us to do things that we really hadn't been able to do before. In addition, the application was built to be data-driven from the very beginning. So we worked with the subject matter experts to figure out every single thing that had to be monitored. So every movement is measured. We're not just giving them an experience, we're tracking every single thing that they do so that we can deliver a performance results analysis at the end that looks something like this. And it's probably a little bit small on the screen here, but if you look at it, you can see that this operator, Dave, came along. He's on his 11th bore. Everything was going well on that first bore. He's pretty much in the green. But then at the second bore, you can see he stopped greasing his threads. And that's when he started dropping rows, and his pitch accuracy fell apart. So a trainer could bring this operator in and say, Dave, you're doing great, but you got to remember to grease those threads. Grease those threads, get them back out into the world. We're not trying to put them through a full training program again. We're trying to figure out what they need help with and train them just on those specific things after they've failed. And the simulator was so successful that Vermeer scaled it. They've got over 50 of these containerized trailer carts where the simulator lives within it, and they're able to deliver it to their dealers. And it became a profit center. They rent these out to their dealers. And so rather than this just being a cost sunk in my company where they are having us build simulators for training, they turn it into a profit center, they sell it, and they are able to generate revenue as well as training. The simulator was also able to scale globally. Vermeer has dealers all around the world. We were able to scale the simulator to reach all these different environments so that, again, training was standardized. Not a different set of training for Europe or Asia, really being able to have standardized training so operators were doing the same thing with the equipment. And so the reason that this application worked was we made the invisible visible. We really worked with our customer to figure out how do we get someone to understand what's happening underground. And then we turned the experience into data. It wasn't just an experience. We were tracking every single metric that they were doing so that that performance analysis results screen really showed them what they needed to know. Excuse me. And finally, it was built for distribution, built into those containerized units, built for the dealer, revenue-generating model, really giving folks the ability to deliver a training simulator to their customers and make money from it. And it worked for a variety of reasons. We were able to accelerate competency, they were able to generate revenue, and we removed all of that risk from training. It's not like in training I can say, okay, go out and just drill it. If you hit that gas main line, well, we'll deal with it. But in our simulator, that's exactly what we're able to do. Really gave the operators a little bit of comfort. Instead of being nervous about the machine, here they were able to make mistakes. And so the insights we gained were tackle those challenges. If they can't see, give them the ability to see what they can't see. Turn the data into a performance analysis module so we can really measure what someone's doing. And then finally, make it mobile. Make it so that it is able to be deployed to a variety of dealers and networks all around the world with a revenue model so it's not just sunk cost. The next case study I'd like to talk about is global ground support. This one's a little bit off the construction path. Global ground support is a major manufacturer of aircraft de-icing trucks. So the environment that they're working in is very harsh. You are dealing with not only large pieces of equipment that are very expensive, but you're dealing with holdover times where you must de-ice an aircraft and get it up in the air before the ice starts to reform. In addition, you've got this glycol fluid, the de-icing fluid, very expensive. So you are dealing with this environment that is very unforgiving. And so the application that we built needed to be able to train people to do this job, right? We weren't able to just train someone on, okay, here's how the equipment works, because what about the weather? And what about the de-icing fluid? And what about the aircraft? And what about the other people working with you? So we had to build a full training environment that did a lot of the things I just mentioned. And so here you see the Global Ground Support Aircraft De-icing Simulator. One of their biggest customers is the US Air Force, and I'll talk about them in a little bit. But essentially what we were able to do is take the real-world controls off this equipment and build a virtual training system, not just a digital replica, but a full virtual training system for this job. And so imagine training for a snowstorm in the middle of July, right? Something that they had to do. You have to keep your operators trained, but there's no snow. So how do you train operators? And what if they don't have the real-world controls? So this previous screen you saw, we took the real-world controls off the simulator, but we're also able to connect it to consumer off-the-shelf controls to make it a much more affordable package to deploy, as well as existing gaming software. Folks who already have computers, we're just able to load the software onto it and really allow them to train without an additional cost. And so what we had to do here was to build this holistic training environment that mimics all of these harsh real-world conditions that operators have to learn to overcome. This is the environment they're going to be working on, so it is necessary for them to overcome these challenges. And so the challenge was really the extreme weather. How do you, again, control the uncontrollable? Typically, they'd have to wait for the weather to be favorable for de-icing conditions. In our simulator, we have a full weather emulator. We can set the time of day, we can set the wind speed, which direction it's coming from, the precipitation type, really giving us the ability to remove that lack of control and suddenly now control the weather. Consumables, massive expense for de-icing. Not only the diesel fuel to run these pieces of equipment, but this glycol fuel that they're spraying, very expensive, very toxic. There's also a cleanup involved in after the job. So there's a lot of costs sunk in the consumables. And so by removing the consumable costs, by making those all virtual, people can train as much as they want to. They can really become masters of these de-icing trucks without having to worry about the costs that they're spending on the glycol fluid or the environmental cleanup that's going to come afterwards. Having virtual consumables really reduces your cost significantly. A lot of those stats I showed originally, that's where a lot of this cost saving comes from. And then finally, the third operation was the distributed complex. So being able to, that's from a different slide. I'm sorry about that. That's from the other example, so I'll skip that one. But really, the impact that we had here was a significant cost savings on just those consumables, like I mentioned, not having to spray glycol fluid, improved readiness. We were really able to develop scenarios that trained for the exact specific situations these folks will be involved in. And it allowed us to deliver much faster crews. These guys have 20 minutes to de-ice an aircraft and get it up in the air before it starts to reset. So we really need these people doing their job, not just effectively, but rapidly. And then we were able to scale. By scaling the simulator to all those different configurations I showed you, we were really able to push it out to a variety of different organizations. The US Air Force, as I mentioned, is the biggest customer of Global Ground Support. They reported they saved over $1 million the very first year they used the simulator in just consumables alone. And so if you're running a training department, you know that saving $1 million from your budget is pretty significant. And so here you're seeing is a fully interactive aircraft de-icing operation inside our simulator. This is a networked multi-user application. People are able to connect on the internet from all around the world and train for the exact operation they may be doing. So tomorrow it may be -20 with the wind coming out of the southwest. You're going to have 4 operators de-icing 16 planes, all different planes. Let's set that up. Let's move them in. Let's practice that exact operation, really giving you the ability to practice the exact operations you're doing with no cost. And again, make the mistakes here. Crash into the airplane, spray into an engine, spray into a valve. Learn that that costs $30,000 or whatever the cost is. Don't make that mistake in the real world. Make it in our simulators. And so the insight that we gained was being able to control that environment by being able to take control of something we had no control of in the past, gave us extreme power. We were able to say, okay, we've got 2 days, let's train for a blizzard that's coming, even though it was the middle of July. We were also able to remove the dependency on consumables, not only the cost of consumables and the environmental impact that I mentioned, but just having access to them. There was a limited budget for how much glycol they could spray, and that directly impacted their training operations. By removing that variability, we were able to scale the training. And then having network training was phenomenal for us. We do not have to have people flying all around the world to conduct training. If we've got different teams in different parts of the world, that's fine. No need to get on an airplane. Really something that we are very proud of and we implement into all our simulators. And so those are the 3 examples I wanted to talk about today, but really it's not about any one of those examples from us. As I mentioned early on, we work for so many different organizations across a wide array of different industry sectors that we're able to see patterns start to emerge. And the patterns were pretty consistent. So by removing those constraints of being able to see underground, of having to use real world weather, suddenly we had the shackles off of us and we could do things at a much faster clip. By making the skills that people are learning measurable, really gave us the ability to track them. So instead of it just being a kind of an experience where you go through training and, okay, you've completed the training, let's check it off. Now we're able to measure every single thing you're doing in the training, what your strengths are, what your weaknesses are, really helping you to identify what you need work on. And then building a scalable infrastructure, being able to allow our simulators to not just run locally or not just run on one device or not just run on one platform, really giving them the ability to be multi-platform, mobile training units, having our dealers rolling them out. That is what drives adoption. And when you have adoption of an application, then suddenly you have success. And so the data showed from kind of an aggregate of all of our clients that we were able to deliver really meaningful results. So faster skill acquisition, 40% faster. That's, not small potatoes when you are faced with increasing schedules and more complicated pieces of equipment. Reducing the training time. There's only a limited amount of trainers. They've got more and more demand on them. If we can reduce the overall training time, it's just less of a stress on the training department. And lower training costs. I mean, this could easily be the #1 thing. Everyone is concerned about costs these days, especially if the price of consumables is always rising, never dropping. If we can lower those training costs, it means you can hire more people, you can move more people through your process. And then less travel. I mean, I love coming out here to Las Vegas. I love all these events, but I'm traveling every 2 weeks sometimes, and it's hard to get your job done when you're always on a flight. So if we can keep our trainers in their location and they can train people all around the world, without having to get on a plane, it is a phenomenal cost and time saver. And then finally, the savings in consumable, I mentioned that over and over, but especially with what's going on in the world today, all we see is the price of oil and the price of gas constantly rising. And it's one of those things that's, again, out of our control, kind of like the weather. So if we can remove that variable from our equation and let people just burn virtual fuel as much as they want so they become the best at what they do, then you've really got an equation for success. So across industries, the data was really consistent. We were able to see the same impact being resolved by different customers, excuse me, across different industries. So that's where we are today. With the remaining few minutes or 10 minutes or so that I have left, I'd like to talk about where we see the industry going. Things are moving so rapidly all the time that it is important to stay at the forefront of technology. And obviously everyone's talking about AI and intelligent systems, and that's where we see our business going as well. So currently, we are doing a lot of work by embedding AI-based subject matter experts into our simulators. We are able to train a large language model on just the specific information about a specific piece of equipment. So all it knows is everything about, let's say, an excavator. And so I can be in the simulator and having a problem, and instead of having to take off the headset or get out of the simulator, I can quickly ask it in natural voice, how does this work? Or how many pounds of torque do I need to put on this wrench? It'll tell me instantly, and I can continue training without having to stop and open up the operator's manual or call a trainer. Next after that is being able to use those same AI subject matter experts, but for operation, not for training. And it's a natural progression, right? Because we've built the AI SME into our software. I'm sure you're all seeing the smart glasses that are coming out by all the different manufacturers. If we run our AI subject matter expert on those glasses now, and you're out in operation, not training, and I'm on that same piece of equipment, and I'm like, wait, how many pounds of torque can I put on this? I've got that same AI SME with me. I can ask it right there, it can tell me, and I can get on with my job. So that is a very natural progression for us where we're seeing AI affecting training as well as operation. And then the final piece of the puzzle is that, many of these companies of ours our customers are building autonomous vehicles. You've probably seen them all out in the yard as well. Now, you don't train autonomous vehicles by just putting them out in the field, right? Waymo didn't just start by putting vehicles out on the streets, although it may have seemed like that in the news. They train them in simulators, right? They have virtual worlds where they train these cars to operate, and then once they are trained, then they can be moved out into the real world. And so we are seeing a big demand for simulation to be used in order to train autonomous vehicles as well. And so where does this all lead? Simulation began as a safe way for us to train people. It became measurable. It now becomes intelligent. And soon, it becomes an environment where both humans and machines learn. And this future really isn't theoretical. It's already happening. If you go out in the field, you'll see a lot of autonomous vehicles, and they are training them in simulation. So don't just take my word for it. The real way to experience VR training simulators is to get inside of them. You have stereoscopic 3D, which I just can't show you on a PowerPoint slide. So if you'd like to see our latest and greatest work, I highly encourage you, right after the session, to head over to the Silver Lot, to the John Deere Extended Reality Live Demo area in their upstairs Innovation Center. They've got the John Deere XR training system that ForgeFX Simulation built for their excavators and dozers there, and you can go experience it right now. And after you've experienced that, come back to my booth in the North Hall N10330, and let's continue this conversation. I'd really like to find out how this technology could help all of you. Thank you very much. Appreciate your time.